then plus j will be a, this is a, plus there is no j here, so this is here 3c plus k, and k is minus 3a times a minus 4 times b minus c is equal to 0. Okay. Now there are three equations here. Okay, and if we are saying that I, j, k are coplanar, each of them individually will be 0, right? So I, j, and k are coplanar. So in general, if we say that, not coplanar, sorry, non-coplanar, right? They are not lying on the same plane. If that's the case, then individually this is 0, this is 0, and this is 0. And if we do that, and if we solve it, I'll leave it to you to solve it, okay? I think it's easy. If you solve it, you should get a to be minus 3, b to be 2, and c to be 1, right? And if that's the case, that you are getting a, b, and c as three different values, okay, what we see is that this is actually nothing but linearly dependent. So this is a way to also solve it, and then say that all these vectors are linearly dependent. Okay, so let's take one example where we actually want to show whether it is linearly independent or not. Okay, so in general, if we actually want to show that it is linearly independent, in general, let's say we have got a vector, okay, ai plus bj plus ck and so on. On a1, a2, a3 may be the coefficients of ij and k. I can write down a1, a2, a3. I hope you know what is a1, a2, a3. So maybe this is a1, this is a2, this is a3, okay, and then b1, b2, b3. So we'll take the coefficients of j, b1, b2, b3, and then we can go for c1, c2, and okay. Now if this is not equal to 0, okay, we basically say that linearly independent. Okay, so that means the three vectors that we are talking about is linearly independent. Okay, or in other words, if you want to prove this as linearly dependent, if this comes out to be 0, that is dependent, and so on. Okay, so you can do these problems. Okay, and based on this, maybe I can just give you one problem. Okay, and this may not be an example, this is just a way to do it. So I'll just give you an example here, and I will give you three vectors, and then you can try doing this. Okay, it's simple. I minus 3j, all are unit vectors here. Okay, plus 2k. So this is a new sum that we need to do, and then this would be 2i minus 4j minus k. Okay, and then we have got 3i plus 2j, okay, minus k. So what you have to do is you have to just prove that this is linearly independent. Okay, so you can try doing this and tell me what is the value that you are getting. Okay, it's non-zero. See if it's true or not. Just check it once and just tell me. It's very easy, should not take time.
So 41. Sir.
Yeah.
So 41.
41. Okay. Anyone else with an answer?
41.
Just confirm if it is 41. Mathematical physics is all about doing a lot of numerical problems. So there are different ways of writing the question. This, even if you solve it later, it's fine. I'm just giving you the pattern of question that might be there. Okay, A, B, C are basically non-coplanar vectors. Okay, and then you have to show that. Okay, let me give those the vectors here. R1 is equal to 2A minus 3B plus C, and R2 is equal to 3A minus 5B plus 2C, and R3 is equal to 4A minus 5B plus C. I have to show that these vectors are linearly dependent. Okay. So if they are not asking for the values of A, B, and C, fine, you can just do the determinant. Okay. Else you can do it in this way, and you can find out the value of A, B, and C also. Doesn't matter. Okay. So sometimes they do mention about this non-coplanar vectors. So when it is mentioning non-coplanar vectors, okay, all these three, it specifically means that you can actually consider this particular idea, and individually the coefficients of I, J, and K will vanish, and you can do your problem. Okay. Okay. So one of you actually got the answer to be 41, right? Anyone else? The determinant 41?
Yes,
Is
sir.
it
I got 41.
41? Okay. So if 2 or 3 of you are getting 41, so we can safely say that it's 41. Okay, so that's
And
correct.
sir, what about the third question? Sir, R1, R2, and R3 denoting what?
This one, R1, R2, R3.
Sir, are there the vectors?
Yes. So
And
A, B, and C are non-coplanar vectors. Okay, so even if they are not mentioning it to be, let's say, unit vector, they're straight away saying that they are non-coplanar. If they are mentioning about I, J, and K, we know that they are non-coplanar. For A, B, and C, it is mentioned they are non-coplanar. If they are non-coplanar, we can use this idea here. We can take up the coefficients of A, B, and C, right? And let me just tell you this. Okay, so you have to basically just take up the determinant here. Okay, that's the easiest way. Take up the determinant, see if it is 0, then that is linearly dependent. Okay, so in general, if you just take it up this way, it's fine. You see, A is nothing but let's say I cap, and how many units of I cap is there is something which is A. Okay, so A I cap, it's mentioned here. So basically, if I write it down as something like this, 2 is just a coefficient which is attached with A. Okay, so this is a different form, and this is a different form altogether. A, B, C are actually nothing but non-coplanar vectors. So in general, if they are linearly dependent, you'll see that they are actually non-coplanar in nature. So for this, what you can do is you can just simply take out the determinant, take these coefficients of 2, 3, minus 3, and 1, and so on, and then show that it is 0. Okay? That
yes,
should be
sir.
the answer. Okay?
So it's proved, sir. 0.
Yeah.
So I got 0.
So, okay, let me give you one more problem here. Okay, this is a slightly different. This one you can do anyway, even if you don't do it now, it's fine. Okay, it's the same thing we are doing. Let's just try doing this sum. Okay, we're just going to understand mathematical physics by doing numericals. I think so. Okay, so if let's say u plus v plus is equal to 0. Okay, and let's say u is equal to 3, the values are given. Okay, v is equal to 5. Okay, and w, okay, is equal to 7. Don't get confused here, I'm talking about vectors here. U, v, w. Okay, and these are the values. Okay, these are the values. Okay, only the magnitude. And prove that, okay, the angle UV. So angle between U and V, okay, is nothing but pi by 3. Again, it's an application of vectors, okay. So think about it, how you can do it, okay, and then probably you can try. You know, U, V and W values are given. You have to find out the angle between U and V, okay. So if you just think about this particular thing, this relation will actually give you the answers. Prove that. The angle inscribed in a semicircle is a right angle. But using vectors, okay. Okay, so this first particular problem, okay, I don't know if only one of you said that done. What about others? Okay, maybe I can ask individually. U plus V here on this side. So it's like vectors. I'll just take a dot product here, and then U plus V is equal to minus W, and then again I will take up plus V. But U plus V is W, I know it, so it is minus W dot W. I'm multiplying it, sorry, okay, not dot product. I'll just take up this as W square, right? And so when this take this up, okay, WW, the angle between them is the same, so we can just take it to be the scalar, not the vector, right? And W value is already given to be 7 square, so that's 49. Okay, directly take it. And on this side it is U plus V bar square equal to, I'll keep it a 7 square only, I guess. And then I think you already know it, right? It's a vector, so you just square it, so it is U bar dot U bar, so it is U square, plus V bar dot V bar, so it is V square, plus 2 times, okay, UV cos of the angle between U and V, right, is equal to 7 square. So now if you just put the values of U and V and do your calculations, you should get cos of UV, okay, and that should be approximately, not approximately, exactly half, okay. So the angle between UV is cos inverse of half, should be pi by 3, right? So we'll do it in this way, and then I don't know, any other ways also possible. ये कैसे लिखा मैंने, ये cos inverse, if I just correct this. So I hope we have solved it this way. Srijita, you have solved it this way, or you have found out any other way? Am I audible? Inscribed in a semicircle. So it's the angle which is actually the interior part inscribed, right? So what we can do is we can actually take this, okay, something like this. So this particular section is nothing but the angle that we are talking about. That means the angle ACB, right? If to talk about A CB. So basically we have to angle AC CB is equal to 90 degrees. That's what you have to prove. Okay. So in general, we can actually consider vectors here, maybe. Okay. So this is A. Let's say this is A. Okay.
Hello, sir.
Yeah. Yes, Sujita, I can hear you
Sir,
now. Tell me.
actually, at that time from my laptop, I could not hear you and could not answer you at all. And sir,
You're trying from your. Can you just repeat? You're trying from your laptop. I heard that. After that.
sir, I could not give you the answer because my speaker was not working.
90 degree means cos of angle ACB. Okay. Must be 0. Right. And in general, we know that AC, let's say this is the vector AC dot CB is equal to AC CB cos of angle between AC and B. Okay, so I'll just take it to be ACB. Okay, so this entire thing you need to basically show to be 0. Okay, so what we can do is we can actually just try to find out AC in terms of A and B. We can try to find out what is CB in terms of A and B, and then we can actually show that AC dot CB is equal to 0. Okay, so we can do it. So let's see what we can do now. We can actually say that AC, okay, is equal to, now if we take up AC, we can actually say it's AO plus OC. Okay, we can take it that way. We can draw the vector diagram in such a way. Okay, we can just say this is AO, this addition of vectors, right, plus OC. So we can just take it to be AO is A bar and OC is B bar. So that's it. Okay, what about CB? Now CB is CO plus OB. So CB is CO plus OB, right? So you know OB is A. OB is in this direction. Okay, we have given the direction here. So OB is A. This is plus A. Okay. But then CB, CO is this, and the direction of vector is in the other way. That means there will be a minus. So CO would be minus B, right? So these are basics of vectors. You have to just practice. So this is A minus B. Okay. So you can just simply take up this AC dot DB is equal to A bar plus B bar dot A bar minus B bar. Okay. So if you do it this way, you know this is A minus B plus B, so it will be A square minus B square. But you know A and B magnitude wise both are nothing but the radii. It's a semicircle. Its a center is O. Okay, O is the center. So O is the center, A bar and B bar are same, right? Basically this is 0. Right? So therefore AC dot CB is 0, that means this part is 0, right? Therefore 1 implies, maybe I can directly write it down as, don't consider this now, okay? This is something which you are doing it later. I'm just giving you an idea before you do the problem, okay? So you can just simply say cos of angle ACB is equal to 0 or CB is equal to 90. So you know when you are doing your maths, low classes, maybe these kind of problems, okay, but then these are important when we're doing even mathematical physics, and we need to solve certain problems, okay, this is actually important. So I think for mathematical physics we can stop here, but then before that I will just give you this particular problem which also you might have done, and here we are talking about a new idea that we have basically got 3 vectors, okay. So maybe this problem, prove that A cross B, okay, cross C plus B cross C cross A plus C cross A cross B is equal to 0. Okay. Campus connection is okay, so I think it's not great, but it's okay. Okay, so